Water covers more than 70% of our planet, and within that vast blue canvas lie 5 great oceans. They are the lungs of the Earth, the drivers of weather, climate, and life itself. From the warm tropical currents of the Indian Ocean to the frozen silence of the Arctic, each ocean tells a different story of movement, depth, connection, and mystery. These are not just bodies of water. They are ecosystems, they are highways of trade. They are homes for millions of species, and billions of people rely on them every single day. The Pacific, Atlantic, Indian, Southern, and Arctic Oceans shape the very fabric of our world, and yet many of us know so little about them. What makes each ocean unique? Why are they critical to Earth's survival? And how are they changing in the face of a warming planet? In this series, we'll explore each ocean one by one. We'll dive into their geography, their wildlife, their importance, and their future. But first, let's understand what they are, how they're connected, and why they matter more now than ever before. Welcome to Earth's 5 great oceans. Let's begin. The world's 5 largest oceans, in descending order of size, are the Pacific Ocean, Atlantic Ocean, Indian Ocean, Southern Ocean, and Arctic Ocean. Here's a list of the top 5 biggest oceans and seas, ordered from largest to smallest. Number 1. Pacific Ocean. The Pacific Ocean is the largest and deepest of Earth's 5 oceanic divisions. It extends from the Arctic Ocean in the north to the Southern Ocean, or, depending on the definition, to Antarctica in the south, and is bounded by the continents of Asia and Australia in the west and the Americas in the east. At 165 million to 150,000 square kilometers in area as defined with a southern Antarctic border, the Pacific Ocean is the largest division of the world ocean. In the hydrosphere and covers approximately 46% of Earth's water surface and about 30% of the planet's total surface area, larger than its entire land area, 148 million square kilometers. The centers of both the water hemisphere and the western hemisphere, as well as the oceanic pole of inaccessibility, are in the Pacific Ocean. Ocean circulation caused by the Coriolis effect subdivides it into 2 largely independent volumes of water that meet at the equator. The North Pacific Ocean and the South Pacific Ocean, or more loosely the South Seas. The Pacific Ocean can also be informally divided by the international date line into the East Pacific and the West Pacific, which allows it to be further divided into 4 quadrants, namely the Northeast Pacific off the coasts of North America, the Southeast Pacific off South America, the Northwest Pacific off Far Eastern Pacific Asia, and the Southwest Pacific around Oceania. The Pacific Ocean's mean depth is 4,000 meters. The Challenger Deep in the Mariana Trench, located in the northwestern Pacific, is the deepest known point in the world, reaching a depth of 10,928 meters. The Pacific also contains the deepest point in the southern hemisphere, the Horizon Deep in the Tonga Trench, at 10,823 meters. The third deepest point on Earth, the Sirena Deep, was also located in the Mariana Trench. It is the warmest ocean, as its temperatures can reach as high as 31 degrees Celsius (88 degrees Fahrenheit) due to its surrounding major and minor Pacific islands, which have a tropical, hot climate. The Western Pacific has many major marginal seas, including the Philippine Sea, South China Sea, East China Sea, Sea of Japan, Sea of Okhotsk, Bering Sea, Gulf of Alaska, Gulf of California, Mar de Grau, Tasman Sea, and the Coral Sea. Number 2. Atlantic Ocean. The Atlantic Ocean is the second largest of the world's 5 oceanic divisions, with an area of about 85,133,000 square kilometers. It covers approximately 17% of Earth's surface and about 24% of its water surface area. During the Age of Discovery, it was known for separating the New World of the Americas from the Old World of Afro-Eurasia, Africa, Asia, and Europe. Through its separation of Afro-Eurasia from the Americas, the Atlantic Ocean has played a central role in the development of human society, globalization, and the histories of many nations. While the Norse were the first known humans to cross the Atlantic, it was the expedition of Christopher Columbus in 1492 that proved to be the most consequential. Columbus's expedition ushered in an age of exploration and colonization of the Americas by European powers, most notably Portugal, Spain, France, and the United Kingdom. From the 16th to 19th centuries, the Atlantic Ocean was the center of both an eponymous slave trade and the Columbian Exchange, while occasionally hosting naval battles. Such naval battles, as well as growing trade from regional American powers like the United States and Brazil, both increased in degree during the early 20th century. And while no major military conflicts have taken place in the Atlantic recently, the ocean remains a core component of trade around the world. The Atlantic Ocean's temperatures vary by location. For example, the South Atlantic maintains warm temperatures year-round, as its basin countries are tropical. The North Atlantic maintains a temperate climate, as its basin countries are temperate and have seasons of extremely low temperatures and high temperatures. The Atlantic Ocean occupies an elongated, S-shaped basin extending longitudinally between Europe and Africa to the east, and the Americas to the west, as one component of the interconnected world ocean. It is connected in the north to the Arctic Ocean, to the Pacific Ocean in the southwest, the Indian Ocean in the southeast, and the Southern Ocean in the south. Other definitions describe the Atlantic as extending southward to Antarctica. The Atlantic Ocean is divided in two parts, the northern and southern Atlantic, by the equator. Number 3. Indian Ocean. The Indian Ocean is the third largest of the world's 5 oceanic divisions, covering 70,560,000 square kilometers, or approximately 20% of the water area of Earth's surface. It is bounded by Asia to the north, Africa to the west, and Australia to the east. To the south, it is bounded by the Southern Ocean or Antarctica, depending on the definition in use. The Indian Ocean has large marginal or regional seas, including the Andaman Sea, the Arabian Sea, the Bay of Bengal, and the Laccadive Sea. Geologically, the Indian Ocean is the youngest of the oceans, and it has distinct features such as narrow continental shelves. Its average depth is 3,741 meters. It is the warmest ocean, with a significant impact on global climate due to its interaction with the atmosphere. Its waters are affected by the Indian Ocean Walker circulation, resulting in unique oceanic currents and upwelling patterns. The Indian Ocean is ecologically diverse, with important ecosystems such as coral reefs, mangroves, and seagrass beds. It hosts a significant portion of the world's tuna catch and is home to endangered marine species. The climate around the Indian Ocean is characterized by monsoons. The Indian Ocean has been a hub of cultural and commercial exchange since ancient times. It played a key role in early human migrations and the spread of civilizations. In modern times, it remains crucial for global trade, especially in oil and hydrocarbons. Environmental and geopolitical concerns in the region include climate change, overfishing, pollution, piracy, and disputes over island territories. Number 4. Southern Ocean. The Southern Ocean, also known as the Antarctic Ocean, comprises the southernmost waters of the world ocean. Generally taken to be south of 60° latitude and encircling Antarctica. With a size of 21,960,000 square kilometers, it is the second smallest of the 5 principal oceanic divisions. Smaller than the Pacific, Atlantic, and Indian Oceans, and larger than the Arctic Ocean. The maximum depth of the Southern Ocean, using the definition that it lies south of 60th parallel, was surveyed by the 5 Deeps expedition in early February 2019. The expedition's multi-beam sonar team identified the deepest point at 60, with a depth of 7,434 meters. The expedition leader and chief submersible pilot, Victor Vesovo, has proposed naming this deepest point the Factorian Deep, based on the name of the crewed submersible DSV limiting factor, in which he successfully visited the bottom for the first time on February 3, 2019. By way of his voyages in the 1770s, James Cook proved that waters encompassed the southern latitudes of the globe. Yet, geographers have often disagreed on whether the Southern Ocean should be defined as a body of water. Bound by the seasonally fluctuating Antarctic convergence, an oceanic zone where cold, northward flowing waters from the Antarctic mix with warmer subantarctic waters. Or not defined at all, with its waters instead treated as the southern limits of the Pacific, Atlantic, and Indian Oceans. The International Hydrographic Organization, IHO, finally settled the debate after the full importance of Southern Ocean overturning circulation had been ascertained. And the term Southern Ocean now defines the body of water which lies south of the northern limit of that circulation. The Southern Ocean overturning circulation is important because it makes up the second half of the global thermaline circulation, after the better-known Atlantic meridional overturning circulation. Much like AMOC, it has also been substantially affected by climate change in ways that have increased ocean stratification, and which may also result in the circulation substantially slowing or even passing a tipping point and collapsing outright. The latter would have adverse impacts on global weather and the function of marine ecosystems here, unfolding over centuries. The ongoing warming is already changing marine ecosystems here. Number 5. Arctic Ocean. The Arctic Ocean is the smallest and shallowest of the world's 5 oceanic divisions. It spans an area of approximately 14,060,000 square kilometers and is the coldest of the world's oceans. The International Hydrographic Organization, IHO, recognizes it as an ocean, although some oceanographers call it the Arctic Mediterranean Sea. It has also been described as an estuary of the Atlantic Ocean. It is also seen as the northernmost part of the all-encompassing world ocean. The Arctic Ocean includes the North Pole region in the middle of the northern hemisphere and extends south to about 60°. The Arctic Ocean is surrounded by Eurasia and North America, and the borders follow topographic features. The Bering Strait on the Pacific side and the Greenland-Scotland Ridge on the Atlantic side. It is mostly covered by sea ice throughout the year and almost completely in winter. The Arctic Ocean's surface temperature and salinity vary seasonally as the ice cover melts and freezes. Its salinity is the lowest on average of the 5 major oceans due to low evaporation, heavy fresh water inflow from rivers and streams, and limited connection and outflow to surrounding oceanic waters with higher salinities. The summer shrinking of the ice has been quoted at 50%. The U.S. National Snow and Ice Data Center (NSIDC) uses satellite data to provide a daily record of Arctic sea ice cover and the rate of melting compared to an average period, and specific past years showing a continuous decline in sea ice extent. In September 2012, the Arctic ice extent reached a new record minimum. Compared to the average extent 1979 to 2000, the sea ice had diminished by 49%. Natural history. Origin of water on Earth. Scientists believe that a sizable quantity of water would have been in the material that formed Earth. Water molecules would have escaped Earth's gravity more easily when it was less massive during its formation. This is called atmospheric escape. During planetary formation, Earth possibly had magma oceans. Subsequently, outgassing, volcanic activity, and meteorite impacts produced an early atmosphere of carbon dioxide, nitrogen, and water vapor, according to current theories. The gases and the atmosphere are thought to have accumulated over millions of years. After Earth's surface had significantly cooled, the water vapor over time would have condensed, forming Earth's first oceans. The early oceans might have been significantly hotter than today and appeared green due to high iron content. Geological evidence helps constrain the time frame for liquid water existing on Earth. A sample of pillow basalt, a type of rock formed during an underwater eruption, was recovered from the Asua Greenstone Belt and provides evidence that water existed on Earth 3.8 billion years ago. In the New Vuajatuk Greenstone Belt, Quebec, Canada, rocks dated at 3.8 billion years old by one study, and 4.8 billion years old by another 40 show evidence of the presence of water at these ages. If oceans existed earlier than this, any geological evidence either has yet to be discovered or has since been destroyed by geological processes like crustal recycling. However, in August 2020, researchers reported that sufficient water to fill the oceans may have always been on the Earth since the beginning of the planet's formation. In this model, atmospheric greenhouse gases kept the oceans from freezing when the newly forming sun had only 70% of its current luminosity. Ocean formation. The origin of Earth's oceans is unknown. Oceans are thought to have formed in the Hadean Eon and may have been the cause for the emergence of life. Plate tectonics, post-glacial rebound, and sea level rise continually change the coastline and structure of the world ocean. A global ocean has existed in one form or another on Earth for eons. Since its formation, the ocean has taken many conditions and shapes, with many past ocean divisions and potentially at times covering the whole globe. During colder climatic periods, more ice caps and glaciers form, and enough of the global water supply accumulates as ice to lessen the amounts in other parts of the water cycle. During the last global warm spell, about 125,000 years ago, the seas were about 5.5 meters, 18 feet higher than they are now. About 3 million years ago, the oceans could have been up to 50 meters, 165 feet higher. Geography. The entire ocean, containing 97% of Earth's water, spans 70.8% of Earth's surface, making it Earth's global ocean or world ocean. This makes Earth, along with its vibrant hydrosphere, a water world or ocean world, particularly in Earth's early history when the ocean is thought to have possibly covered Earth completely. The ocean's shape is irregular, unevenly dominating the Earth's surface. This leads to the distinction of the Earth's surface into a water and land hemisphere, as well as the division of the ocean into different oceans. Seawater covers about 361 million square kilometers and the ocean's furthest pole of inaccessibility, known as Point Nemo. In a region known as Spacecraft Cemetery of the South Pacific Ocean, at 4852.6 S1 to 323.6 W, this point is roughly 2,688 kilometers from the nearest land. Physical properties. Most of the ocean is blue in color, but in some places the ocean is blue-green, green, or even yellow to brown. Blue ocean color is a result of several factors. First, water preferentially absorbs red light, which means that blue light remains and is reflected back out of the water. Red light is most easily absorbed and thus does not reach great depths, usually to less than 50 meters. Blue light, in comparison, can penetrate up to 200 meters. Second, water molecules and very tiny particles in ocean water preferentially scatter blue light more than light of other colors. Blue light scattering by water and tiny particles happens even in the very clearest ocean water and is similar to blue light scattering in the sky. The main substances that affect the color of the ocean include dissolved organic matter, living phytoplankton with chlorophyll pigments, and non-living particles like marine snow and mineral sediments. Chlorophyll can be measured by satellite observations and serves as a proxy for ocean productivity, marine primary productivity in surface waters. In long-term composite satellite images, regions with high ocean productivity show up in yellow and green colors because they contain more green phytoplankton, whereas areas of low productivity show up in blue. Water cycle, weather, and rainfall. Ocean water represents the largest body of water within the global water cycle. Oceans contain 97% of Earth's water. Evaporation from the ocean moves water into the atmosphere to later rain back down onto land and the ocean. Oceans have a significant effect on the biosphere. The ocean as a whole is thought to cover approximately 90% of the Earth's biosphere. Oceanic evaporation, as a phase of the water cycle, is the source of most rainfall, about 90%, causing a global cloud cover of 67% and a consistent oceanic cloud cover of 70%. Ocean temperatures affect climate and wind patterns that affect life on land. One of the most dramatic forms of weather occurs over the oceans. Tropical cyclones, also called typhoons and hurricanes, depending upon where the system forms. As the world's ocean is the principal component of Earth's hydrosphere, it is integral to life on Earth, forms part of the carbon cycle and water cycle, and as a huge heat reservoir, influences climate and weather patterns. The motions of the ocean's surface, known as undulations or wind waves, are the partial and alternate rising and falling of the ocean's surface. The series of mechanical waves that propagate along the interface between water and air is called swell, a term used in sailing, surfing, and navigation. These motions profoundly affect ships on the surface of the ocean and the well-being of people on those ships who might suffer from seasickness. Wind blowing over the surface of a body of water forms waves that are perpendicular to the direction of the wind. The friction between air and water caused by a gentle breeze on a pond causes ripples to form. A stronger gust blowing over the ocean causes larger waves as the moving air pushes against the raised ridges of water. The waves reach their maximum height when the rate at which they are traveling nearly matches the speed of the wind. In open water, when the wind blows continuously, as happens in the southern hemisphere in the roaring 40s, long, organized masses of water called swell roll across the ocean. If the wind dies down, the wave formation is reduced, but already formed waves continue to travel in their original direction until they meet land. The size of the waves depends on the fetch, the distance that the wind has blown over the water, and the strength and duration of that wind. When waves meet others coming from different directions, interference between the two can produce broken, irregular seas. Constructive interference can lead to the formation of unusually high rogue waves. 84 Most waves are less than 3 meters 10 feet high 84, and it is not unusual for strong storms to double or triple that height. Rogue waves, however, have been documented at heights above 25 meters. The top of a wave is known as the crest. The lowest point between waves is the trough, and the distance between the crests is the wavelength. The wave is pushed across the surface of the ocean by the wind, but this represents a transfer of energy and not horizontal movement of water. As waves approach land and move into shallow water, they change their behavior. If approaching at an angle, waves may bend refraction or wrap around rocks and headlands diffraction. When the wave reaches a point where its deepest oscillations of the water contact the ocean floor, they begin to slow down. This pulls the crests closer together and increases the wave's height, which is called wave shoaling. When the ratio of the wave's height to the water depth increases above a certain limit, it breaks, toppling over in a mass of foaming water. This rushes in a sheet up the beach before retreating into the ocean under the influence of gravity. Earthquakes, volcanic eruptions, or other major geological disturbances can set off waves that can lead to tsunamis in coastal areas, which can be very dangerous. Sea level and surface. The ocean's surface is an important reference point for oceanography and geography, particularly as mean sea level. The ocean's surface has globally little but measurable topography depending on the ocean's volumes. The ocean's surface is a crucial interface for oceanic and atmospheric processes, allowing interchange of particles, enriching the air and water, as well as grounds by some particles becoming sediments. This interchange has fertilized life in the ocean, on land and air. All these processes and components together make up ocean's surface ecosystems. Tides are the regular rise and fall in water level experienced by oceans, primarily driven by the Moon's gravitational tidal forces upon the Earth. Tidal forces affect all matter on Earth, but only fluids like the ocean demonstrate the effects on human timescales. Though primarily driven by the Moon's gravity, oceanic tides are also substantially modulated by the Sun's tidal forces, by the rotation of the Earth, and by the shape of the rocky continents blocking oceanic water flow. Tidal forces vary more with distance than the base force of gravity. The Moon's tidal forces on Earth are more than double the Sun's, 91, despite the latter's much stronger gravitational force on Earth. Earth's tidal forces upon the Moon are 20x stronger than the Moon's tidal forces on the Earth. The primary effect of lunar tidal forces is to bulge Earth matter towards the near and far sides of the Earth relative to the Moon. The perpendicular sides, from which the moon appears in line with the local horizon, experience tidal troughs. Since it takes nearly 25 hours for the Earth to rotate under the moon, tides thus cycle over a course of 12.5 hours. However, the rocky continents pose obstacles for the tidal bulges, so the timing of tidal maxima may not actually align with the moon in most localities on Earth, as the oceans are forced to dodge the continents. Timing and magnitude of tides vary widely across the Earth as a result of the continents. Thus, knowing the moon's position does not allow a local to predict tide timings, instead requiring pre-computed tide tables which account for the continents and the sun, among others. During each tidal cycle, at any given place the tidal waters rise to maximum height, high tide, before ebbing away again to the minimum level, low tide. As the water recedes, it gradually reveals the foreshore, also known as the intertidal zone. The difference in height between the high tide and low tide is known as the tidal range or tidal amplitude. When the sun and moon are aligned full moon or new moon, the combined effect results in the higher spring tides, while the sun and moon misaligning half moons result in lesser tidal ranges. In the open ocean, tidal ranges are less than 1 meter, but in coastal areas these tidal ranges increase to more than 10 meters in some areas. Some of the largest tidal ranges in the world occur in the Bay of Fundy and Ingava Bay in Canada, reaching up to 16 meters. Other locations with record high tidal ranges include the Bristol Channel between England and Wales, Cook Inlet in Alaska, and the Rio Gallegos in Argentina. Tides are not to be confused with storm surges, which can occur when high winds pile water up against the coast in a shallow area, and this, coupled with a low-pressure system, can raise the surface of the ocean dramatically above a typical high tide. The average depth of the oceans is about 4 kilometers. More precisely, the average depth is 3,688 meters. Nearly half of the world's marine waters are over 3,000 meters deep. Deep ocean, which is anything below 200 meters (660 feet), covers about 66% of Earth's surface. This figure does not include seas not connected to the world ocean, such as the Caspian Sea. The deepest region of the ocean is at the Mariana Trench, located in the Pacific Ocean near the northern Mariana Islands. The maximum depth has been estimated to be 10,971 meters (35,994 feet). The British naval vessel Challenger surveyed the trench in 1951 and named the deepest part of the trench the Challenger Deep. In 1960, the Trieste successfully reached the bottom of the trench, manned by a crew of 2 men.
you.